Okay, so today we will study about the distance properties of the convolutional code. So basically, the question will be asked in your examination, like what is the minimum Hamming distance, or that Hamming distance minimum. Okay, what do you say about minimum Hamming distance? So we will see. So we will see how to calculate the minimum Hamming distance from actually two procedure. First of all, state diagram. So it's modified state diagram, and again from the trellis diagram. Okay, so from two method, like from the modified state diagram and from trellis diagram, we will calculate the minimum Hamming distance. So before we start, first of all, we have to know two basic thing. One is called the Hamming distance. What is the Hamming distance, and what is the weight of the code? Okay, weight of the code. I think you have already known to this two terms because you have already studied in your linear block code. So first of all, okay, so first of all, this is a general Hamming distance. So what is the Hamming distance? Hamming distance is nothing but the minimum value of the distance, the Hamming distance, or the minimum value of the distance between two codes. Or you can say, suppose two code sequences are given, one is 000 and one is 010. So how many dissimilarities are there in the bit positions? Okay, the first position is same 00, the third position is also same 00, but in the second position there is a dissimilarity. So 0 for the first sequence and 1 is for the second sequence. So there is one dissimilarity between these two code sequences. So the Hamming distance will be 1. So number of the dissimilarities between two code sequences is basically the Hamming distance between two codes. So like 101 is given, suppose 101 is given and 111 is given. So how many dissimilarities of bit present in between these two code sequences? So basically you can see that the first position two bits are same, the third position two bits are also same, but the second positions we have a dissimilarities between two bits. Okay, 0 and 1. So the Hamming distance is 1. So number of the dissimilarities present in between two code sequences is basically the Hamming distance between two bits. Okay, so this is the basic thing to know before we start the minimum Hamming distance. So another basic thing is the weight of the code. So you have already know that what is the weight. Weight basically stands for the number of the ones present in one code sequence. Like you can see, you can take this example like 010. Okay, I'm just showing this example. From this example 010, so the number of the ones is 1. Okay, from this 111, the number of the ones, the number of the ones present in this code sequence is 3. So 3 number of ones present in this code sequence. So weight of this code is 3. So weight of the code 010 is 1 because the number of 1 present in this code is 1. Only one is present in this code. So that's why if you can consider that when I'm calculating 000, when I'm calculating the Hamming distance between 000, that means all 0 code, it is to be considered as all 0 code. It may be 2-bit representation, it may be 3-bit representation, so whatever it may be, but you know that all 0 bit representation, if this is 00 and this is 01, so suppose I'm taking this example as my bit is 00 and 01. Okay, 00 and 01. So I'm calculating the Hamming distance between these two. So what is the Hamming distance? So the dissimilarities present is 1 because 00, the first position bit is same, but the second position bit is different. So 0 and 1. So Hamming distance is 1. And what is the code of the second bit? What is the weight of the second code sequence? This is also 1. So you know that when any code bit, okay, when the Hamming distance has been calculated between all 0 bit and any code bit, then the Hamming distance will be equal to the weight of the second bit. Okay, so from this example you can say that, but consider this example like 000 and 010. So for example, this example, so I'm taking this example again. Okay, so I'm taking this example like 000 and 010. Okay, so for this, the Hamming distance, what is the Hamming distance between this all zero bit? I'm just signifying it by all zero bit and any bit which may be 010, which may be 101, any bit. Okay, any bit which is called B, which is defined as B, and all zero bit is defined as A. Okay, so I'm calculating the Hamming distance between this two bit, all zero bit and any bit. Okay, so for this example, the Hamming distance is 1 because the first position sequence is same, the third position sequence is also same, but the second, there is a dissimilarity present in second place. Okay, so the Hamming distance is 1. And if you see that what is the code weight, okay, weight of the code of the second code sequence is also 1. So the Hamming distance between all zero bit and any bit is equal to the weight of the weight of the code sequence, which is being I'm just repeating it. Actually, I'm trying to say whenever calculating the Hamming distance between all zero bit with any bit, then it will be equal to the weight of that any bit. Okay, so here I'm taking all zero bit as 000, that is 3-bit representation, and also any bit as 010. So number of dissimilarities is 1. So Hamming distance is 1. So here it is written that two code sequences and Hamming distance between A and B is 1. And also the code weight. I'm trying to say that the code weight of WB, that means I'm taking B equals to 010. So WB means weight of B. The code weight of B is also 1. So you know that the Hamming distance is 1 and code weight of the B is also 1. Okay. So I'm trying to say that, let me erase it. Okay. So I'm trying to say that when you are calculating distance, you know that when you are calculating distance of any bit sequence with respect to all 0-bit sequence. Okay. So when you are calculating the distance of any bit sequence with respect to all 0-bit sequence, like this 000 and 010. So when you are calculating the distance of any bit means 010, that is defined by B, right? So this bit with respect to all 0-bit, sequence or all 0 code, the Hamming distance, note that the Hamming distance will be same as the weight of that code. That means that code means this any bit code. Okay, if you are calculating the Hamming distance between all zero code, if you're calculating the Hamming distance between all 0 code and 010 or any bit, any code, okay, or you can say if you're calculating the distance, between all 0 code and any code, okay, that means you are calculating with respect to all 0 code. Okay, so then that will be your Hamming distance, and that will be equal to the code you are considering with respect to 000. Okay, so that any bit code. So the Hamming distance of this two code sequence will be equal to the weight of this second code sequence. Okay, so as you can see, the Hamming distance is 1 and the weight of code B is also 1. So in this way, I'm taking another example for your understanding purpose. So let me just erase it first. Okay, so for example, this is A equals to 0, 0. Suppose I'm taking A equals to 0, 0 and B equals to 0, 1. Okay, So what is the Hamming distance? Hamming distance equals to